So for the last part of this paper, question 10, we have been given a curve y. So this is our curve y, and this is the function for it, and it has a minimum point, as we can see, at m, and this minimum point occurs when x is equal to a. So for this, the coordinates would be a comma y, because we don't know the y value yet. Now we also know that minimum points occur when dy over dx equals to 0. So for the first part A, we need to show that a satisfies the equation tan a is equal to half a. So let's do that. Now we've been given that y is equal to root x cos x. So as we can see, these are two products of a function. So we are going to use product rule to find dy by dx. So we can let u is equal to under root x and v is equal to cos x. And for anyone that does not know product rule, it is dy by dx is equal to u prime v plus v prime u. So u prime would be 1 over 2 root x. That is the very basic differential, we all know this. Now v prime would be minus sine x. So if we put this into our equation, we will have 1 over 2 root x times cos x plus root x times v prime, which is minus sine x. And now we need to equal this to 0. So, and we also have to plug in a, because our minimum point where dy over dx equals 0 is where x is equal to a. So we will equate it to 0 and we will replace x with a. So we will get cos a over 2 root a plus, minus, because of the minus sine x, minus root a times sine a. Now we will send this to the other side and we will get root a sine a is equal to cos a over 2 root a. And if I just write this here, because we're running out of space, if we put sine over cos and we send cos to the bottom here, we will get root a is equal to, sine over cos is tan, y equals to root a tan a is equal to 1 over 2 root a. So we can see that we have tan a over here, and if we send this to the other side and make tan the subject, we will get 1 over 2 root a times this root a. So both of these will multiply and the roots will cancel each other, and we will just be left with 2a. And that is what we had to show. Now in part B, we have been told to use the iterative formula, and we have been told that the initial value of x is 3 and it converges to a. And we need to give the answer for a correct to 2 decimal places and the result of each iteration to 4 decimal places. So let's do that. It's very simple. So we've been told that the first value of x is 3, and for this it's very easy. We just need to put this formula into the calculator, but make sure that your calculator is in the radian settings, and then we will just do pi plus tan inverse 1 over 2, and we will keep clicking the answer to get our iterative values. So if we just use the calculator, our second value is coming out to be 3.3067. Our third value, if you click answer again, is 3.2917. And our fourth value should be 3.2923. Our fifth value is coming out to be 3.2923 as well. And just once again, our sixth value will be 3.2923. And so correct to 2 decimal places, we can conclude that our answer for A is 3.29. So very easy marks, just one mistake, you could not have your calculator in radian setting, and that would just cost you it. Besides that, very simple. Now for part C, we have a 6-mark question. We have to find the volume of the solid obtained when the region R is rotated completely about the x-axis. So for this, we need to know what formula to use, and let me write that down for you. So when the volume is being rotated around the x-axis, we use the pi integral of y square dx. So our function of the curve is given to us as y is equal to root x times cos x. So we know that y square would be x cos square x. Okay, so we know that we are finding pi integral of x cos square x dx. Now we need to find the region R. So as you can see on the graph, the region R is located between 0 and this point. Let's call it x. So first we need to find this point. Now we know that on the curve, this part is where y is equal to 0. So we can equate our function to 0 because we know that the value of y is 0 since it's hitting the x-axis. And we will find the values of x. So root x is equal to 0 and the value of x is equal to 0. But we already know this because of one border that was already given to us. So we need to find cos x equals to 0. And if we do, x is equal to cos inverse of 0, that gives us pi by 2, which is 90 degrees. So this part is pi by 2. So now we have the limits we need to use for this integral. Now, since this is cos square, that makes it a little difficult for us. So we're going to find a formula that will make it simpler. So in the list of formulas, we are given this cos 2a is equal to 2 cos square a minus 1. So if we rearrange that and make cos 2 cos square a the subject, we get if we make just cos square a the subject, we have cos square a is equal to cos 2a plus 1 divided by 2. Because of this, we made cos square a the subject. So now if we replace this in our main formula, we can take the pi out to make it simpler for us, and in the integral we will have x times cos square x. We are replacing by cos 2x plus 1 over 2 dx. Now let's multiply the x in, and we can take this denominator out as well for our convenience. So we have pi over 2 integral x times cos 2x, and x times 1 will just be plus x dx, and our limits were pi over 2 and 0. Now this is a very lengthy equation, so to simplify it and make sure we don't do any mistakes, let's separate it. So pi by 2 is out, and let's put a big square bracket here. So we have integral of pi by 2 and 0 x cos 2x, and then plus the integral with the same limits of x dx. Dx here as well. Close the bracket. So let's solve this part first. So x would simply be integrated to x squared over 2 with these limits. So let's plug them in and simplify. Pi over 2 whole square would be pi square over 4 divided by 2. And this, if we plug in 0, that would just be 0. So let's not write it. And we will get pi square over 8 from this. Now, for this part, we have one algebraic expression and one trigonometric expression. So we will need to use integration by parts. So now the formula that we have to use for this, I'm sure it's given in the list of formulas, but we have the, let me write down for you here, u dv with the integral of that is uv minus integral du over dx times v dx. So first we need to choose what will be our u and what will be our dv. So for that we will use the expression late, and so we can see that we have algebra and then trigonometry. So since a comes first, so algebra will be u, and then our trigonometric expression will be dv. So we have u is equal to x and dv is equal to cos 2x. Now du over dx will be 1, and for dv to find, we will find the integral, and that will be sine 2x over 2. Now let's replace this into our main expression. So for u we have x, and then for v we have sine 2x over 2, and then minus integral of du over dx. So that is 1 times v, which is sine 2x over 2 times dx. And now we just need to keep simplifying. So we have x over 2 sine 2x minus the integral of this is minus cos 2x over 4, and then we have our limits pi over 2 and 0. So if we substitute that in, we have pi over 4 sine pi plus, because the minus and minus will become plus, cos pi over 4 minus this will become 0, and then cos 0 over 4. So let's check what these values are. So pi over 4 times sine pi would become 0, and cos pi over 4 is minus 1 over 4, and then cos 0 is also 1, so that is just minus 1 over 4. So minus 1 over 4 and minus 1 over 4 will give us minus half. And finally, we had solved this 6-mark question and reached the end of our paper. I hope you understood everything, and if there is any questions or anything that you are still unclear about, please reply in the comments and I'll be happy to explain it some further.